In this video, we're going to go through the extra help section for 4.2.2 multiplication. And this is on page 6 in the packet, but you could also just use regular paper. And we learned two methods for multiplication of polynomials, the distributive method and the box method. And you can definitely choose which one is your favorite and use that every single time, but it usually makes the most sense to switch it up between problem to problem. And what I typically do is anything that has two terms or less, I will use the distributive, and then anything bigger than that, I'll use the box. So for this first one, for example, both of these have two terms. And so I would use the distributive method. And with that method, we're going to distribute the first term to everything in the second, and then repeat that process for the second term. So I'm going to distribute negative 6p times 2p. And for multiplying, you multiply the coefficients to get negative 12, and then you add the exponents to get p squared. Then I go back to my first term and I distribute again to anything that's left in the second polynomial. Negative 6 times negative 8 is positive 48p. And then you go ahead and repeat that process for anything left in the first polynomial. So we're going to multiply 1 times this, and 1 is nice because 1 times anything is itself. So 1 times 2p gives me positive 2p, and 1 times minus 8 gives me minus 8. So once you have distributed the first term and the second term to everything in the second polynomial, you're going to want to combine like terms and make sure your answer is in standard form, so in order. And usually your like terms are in the middle. And so we get negative 12p squared plus 50p minus 8. And this is in order and simplified, so this is our answer. And so now for anything longer, I usually use the box method. So you can see this one has 3 terms, and so I would use the box method for this one, because my arrows will just get out of control the bigger the polynomials are. So I'm going to draw a box with the same dimensions as my polynomials. So 3 across and 2 up and down. And then I'm going to match up my polynomials with my rows and columns. And with the box method, you're just going to do the same process as distributing. You're going to multiply, but we're going to multiply each part of each row and column to get the inside of the box. Just like a Punnett square in biology, where you take this row and this column to get this inside piece. In our case, we're going to multiply our coefficients and add our exponents. So I like to draw in if there's ever an exponent of 1 so I don't forget it. 3 times 4 gives me positive 12. I have 3 x's and 1 x to give me 4 x's. 2 times 3 gives me 6, and then I have 1 x and 1 x to give me x squared. Negative 8 times 3 gives me minus 24, and I have 1x. Then go down here. 4 times negative 9 gives me negative 36, and then I have x to the third. 2 times negative 9 gives me minus 18, and I have 1x. And negative 8 times negative 9 is positive 72. So once you have everything in your box, I like to look for any like terms. And so I have 1x to the fourth, 1x to the third, 1x squared. But these are like terms. So I like to just kind of put a box or a circle around them. So that when I pull them out of the box, I can combine my like terms all in one step. So I have 12x to the fourth minus 36x to the third plus 6x squared, and then combine. So minus 18 plus minus 24 gives me negative 42, and then 72. So now we have this in order. Everything, all my like terms are combined. And so this is my answer. So that's just a recap on both methods. There are more videos on this on the class website if you wanted to look at them. But kind of what you want to do is for smaller ones, distribute, and for bigger ones, use the box.